Today is an extension from yesterday's lesson. It's pretty much another way to manipulate a function when looking for a limit algebraically. So the do now first asks you to simplify the complex fraction. So on note card 7, I had given you two methods of simplifying a complex fraction, which is a fraction within a fraction. I was going to show you both ways on this one. One of the methods is much easier in this case, but I guess I'll still do it both ways to show you. I'm not even making a new note card for today because really it's just going back to note card 7 to manipulate the function and then plugging in after. So the first method I used for simplifying a complex fraction was to get a common denominator on top and a common denominator on the bottom. In this case, the bottom already is just x minus 12, so I could put the bottom over 1. But the top, I could get a common denominator of 12x. So this fraction would have to be multiplied by 12 on top and bottom. Oh, sorry. And the second fraction would have to be multiplied by x on top and bottom. And that would give us 12 over 12x minus x over 12x. So we would be making it the top is 12 minus x over the common denominator 12x, and then we're dividing that by x minus 12 over 1, the bottom fraction I'm just bringing over. So then we flip and multiply 12 minus x over 12x times 1 over x minus 12. X minus 12 and 12 minus x, reverse subtraction, so we'd have a negative 1 on top. So it's negative 1 on top, 12x on the bottom, and that's our simplified complex fraction, which means we no longer have a fraction within the fraction. It's just a numerator and a denominator. Okay, the other method, and that some of you chose to do, though this is actually what I usually prefer, but in this case, it's actually not better. Actually, I'm not going to rewrite it. I'm just going to do it right next to. Would be to clear the denominator. So again, this bottom fraction is just the x minus 12 over 1. So the LCD of the top and the bottom would just be 12x. So I multiplied every fraction by that 12x, including the bottom. And then we would clear the denominator. So on top, the x's go. And the first term, we're just left with the 12 times 1, which is 12. Minus here, the 12s cancel, and we have 1 times x, which is x. Divided by, on the bottom, nothing cancels out. So I'm going to have to distribute the 12x and multiply it. And I get 12x squared minus 144x. So the bottom could be factored, and then we would simplify. So I could factor out a 12x, common denominator, and I'd get x minus 12. And then we'd be able to simplify and be left with the same thing. X minus 12, 12 minus x is minus 1. So it's minus 1 over 12x. So I guess that wasn't that much harder. Okay, so either way we get the same answer. That's card 7 again if you want to get yourself familiar again with simplifying a complex fraction. So now applying that to a limit, like here. If I were to plug 0 into this complex fraction, the denominator is just x. It would be a 0 in the denominator, undefined. So we are going to look for a method to manipulate because direct substitution wouldn't work. Okay, we can't directly substitute. There's no factoring and dividing out a common factor. Yesterday, rationalizing, there's no radicals here. When there's a complex fraction, the way to manipulate is to get rid of the complex fraction. So this is over 1 on the bottom. So again, we have the two methods we could use to manipulate this. We can get a common denominator on top and subtract those two fractions, and then flip and multiply. Or we can multiply all three fractions by the common denominator and clear it. Maybe I'll do this one both ways too, and then I'm going to have to stop. So the common denominator is 5 times x plus 5. So I'd be multiplying the bottom and top here by 5. And x plus 5 times x plus 5 here. So on top I would get 5 over 5 times x plus 5 minus x plus 5, because 1 times x plus 5 over 5 times x plus 5. So I'm just simplifying the top. So on top, if I distribute the minus, I get negative x, and then it would be 5 minus 5, so that's 0, over the 5 times x plus 5. So that's what the top simplifies to. So I'm going to be doing the negative x over 5 times x plus 5 divided by the x over 1. Flip and multiply. The x over x minus, the over x over 1 is just bringing it down. First fraction comes down. Change to multiplication, flip. The x's cancel, but we still have a negative 1 on top because of the negative x. So here we get a negative 1 on top, 5 times x plus 5. So that's the manipulated function. Now we could substitute 0 in for x and get a value. Negative 1 over 5 times 0 plus 5 is equal to negative 1 over 5 times 5, which is 25. Yeah, I'm not doing that both ways. Maybe I'll do the next one with clearing the denominator. Okay, so getting a common denominator on top, it's always tricky here when you have this minus sign with that binomial here. So you would have had to realize to distribute that negative 1 there. If it was a plus sign, it wouldn't be a problem. I have 4 more of these. I can't imagine a child's not going to interrupt, and I'm going to have to start another video. But for now, let's keep going. Okay, a common denominator here is 3x. So this one, I'm going to do the other method to manipulate. By the way, if I plug 3 in the way it is now, it would be 1/3 minus 1/3 on the bottom, which would be 0. So that's why we have to manipulate. So we're going to make this, smaller. So I'm going to multiply the top by 3x and multiply each fraction on the bottom by 3x. So 3x and 3x. These are over 1. So on top, so this is the other method, the clearing the denominator. When I distribute the 3x, I get 3x squared minus 9x on top over. On the bottom, the x's cancel, so I'm left with 3 times 1 for the first term, minus sign. The 3's cancel, and I have 1 times x, which is x. So now it's not a complex fraction anymore, though I still can't sub in right now. Now I have to divide out a common factor. So on top, I could pull out a 3x, and I get x minus 3 over 3 minus x. So x minus 3 and 3 minus x cancel. I have a negative 1 there because it's reverse subtraction. And it's negative 3x. Now I could plug the 3 in here. Negative 3 times 3, the limit is negative 9. Okay. Number 2, I'll use the same method as there. 3 and 4, I'll do the other method. So here, again, the common denominator is 6 times x plus 6. So each of the fractions on top, I'm going to times by 6 times x plus 6. 6 times x plus 6. And then on the bottom, 6 times x plus 6. and let's watch what happens. I'll keep the red. X plus 6 cancels. 6 times 1 is 6 minus. The 6's cancel. Again, I have this negative 1 that I'm going to distribute. So the negative 1 times the x gives me negative x. The negative 1 times 6 gives me negative 6. And then on bottom, x times 6 is 6x. There's no denominator on the bottom to cancel anything, so we just times across. And then times x plus 6. Okay, on top, we end up with the 6 minus 6 is 0, so we just have negative x over 6x times x plus 6. The x's cancel. We have a negative 1 left on top. 6 times x plus 6 on bottom. So negative 1 on top. We could plug the 0 in on bottom. So it's 6 times 0 plus 6. So it's negative 1 over 6 times 6, 36. Okay? So if you want to do the clearing the denominator method, you could just follow 1 and 2. Those of you that want to do getting a common denominator, flipping and multiplying, that's how I'm going to do 3 and 4. Feel free to comment on the lesson if you need more help with either method. Okay, so here the 2 minus x is over 1. So I have 2 minus x over 1 divided by, I need to get a common denominator on bottom. So I have times x. The second one's going to be times 2 times 2. So I have x over 2. Oh, I'm not going to do it there yet. I'll do it there when it's... I have x over 2x minus 2 over 2x. So I have x minus 2 on top over 2x. Then I'm going to flip and multiply. Coming.